Welcome to the Rockwell Collins Multiscan Radar computer-based training program. Let's jump right in and look at multiscan controls and displays. The Airbus Radar Control Panel System switch is a 3-position switch. The center position turns the system off. The number 1 position selects the left receiver transmitter, or RT, and the right position selects the right RT. The predictive wind shear switch disables the automatic wind shear features. Today's digital, low-power radars are not a significant radiation hazard. It is recommended that this switch be left in the auto position. The multiscan switch toggles between the radar's auto and manual modes. During manual operation, the ND displays MAN in front of the tilt code. During auto operation, tilt code stands alone. When the radar is in auto, the radar's automatic threat and weather detection features are activated. In manual, the radar works exactly like traditional radar. Weather radar is, of course, all about showing weather. When the radar is in auto, multiscan eliminates the ground clutter and displays the weather out to 320 nautical miles. In these pictures, note the absence of ground clutter and the thunderstorm cells at 60, 130, and 180 nautical miles. In addition, the radar displays a 4th cell that is over the horizon. The yellow arc is a pack alert function and warns crews that the cell at 60 nautical miles is attenuating the radar beam, and the area behind the cell is not visible to the radar. Pack alert is active in manual and auto, in cal gain only. One significant difference between multiscan in auto and a traditional radar is that weather below the aircraft flight path, or non-threat weather, is not displayed. Multiscan uses the quiet dark cockpit philosophy. In other words, if the weather is not a threat because it is not in the aircraft flight path, it is not displayed. Note the flight path vector on the HUD display, and also note that it is intersecting the 0-degree pitch line, indicating that the aircraft flight path is above these cells. Also note that the display shows a clean screen, since the non-threat weather is not displayed. Weather that is not in the aircraft flight path is often visible from the cockpit, and there are occasions where it may appear that cells should be displayed, but are not. For instance, this cell is not displayed, but is it at the aircraft altitude? How about now? The fact is that this is a post-convective cell. On close approach, it can be seen that there is no substance to the cell. In fact, you can see right through it. In addition, the cell is 1,000 to 2,000 feet below the aircraft and thus not a threat. Again, applying the quiet, dark cockpit philosophy, this non-threat cell is not displayed. A quick note on radar beam width. Although a 3-degree radar beam is pretty narrow, the fact is that at 80 nautical miles, it is already 25,000 feet in diameter. What this means is that even when the radar uses multiple scans, the height estimation of the cell becomes more and more coarse the further the cell is from the aircraft. So, on occasion, weather that is initially visible at longer ranges may fall off the display as it approaches the aircraft, and the radar can better determine the cell heights. The Weather plus Turb mode displays weather returns and turbulence out to 40 nautical miles. This NEXRAD presentation shows a significant cell, which is also visible out the window of the aircraft. A blow-up of the NEXRAD view and the radar view shows the magenta turbulence on the radar display and its correspondence with the NEXRAD data. Weather plus Turb is the recommended operating mode. A nuisance turbulence alert has been observed between 10,000 and 20,000 feet in non-convective or stratiform rain. This results from oversensitivity in the turbulence algorithms and will be corrected in future software updates. If you are in non-convective weather between 10 and 20,000 feet, the turbulence indication may be considered a nuisance alert. Turb mode presents just the magenta turbulence indication without the green, yellow, and red weather depictions. Turb mode should be used on a momentary basis, only to identify areas of turbulence. Pilots should then return to the weather or weather plus turb mode so that the full extent of the weather system is visible. Map mode displays all the information that the radar sees, both ground and weather returns. The ground clutter suppression switch is similar to map mode, except it is a spring-loaded momentary function. The tilt control is inactive during auto operation. Full above and below calibrated gain is available during both manual and auto operation. In manual calibrated gain, standard radar reflectivity of rain rates are displayed. An increase or decrease of 10 dB of sensitivity represents a change of one color level. Increasing the gain to max increases the sensitivity by 16 dB, or an increase of 1.5 color levels. Yellow will display as red, and green will display as yellow or red. In addition, areas of black may display as green or yellow. Conversely, selecting minimum gain decreases the sensitivity by 14 dB and reduces the color levels approximately 1.5 times. Thus, green returns and a significant portion of the yellow returns will disappear, and red will turn to yellow or green. Essentially, in min gain, only thunderstorm cores are displayed, and they will be represented as green or yellow. Min gain should be used for momentary weather evaluation only, and then the gain should be returned to the cal gain position in order to avoid underrepresenting thunderstorm threats. Let's explore gain in auto mode a bit further. A typical thunderstorm is very reflective below the freezing level. However, the top third of the storm tends to be glaciated and non-reflective. As an aircraft climbs, the radar beam moves higher in the cell, and at cruise altitudes can overscan the reflective portion of the cell, resulting in inadvertent thunderstorm top penetration. In auto mode, Multiscan uses an automatic temperature-based gain to reduce this threat. As the aircraft climbs and the outside air temperature decreases, the radar automatically increases gain to compensate for the lower reflectivity of upper-level thunderstorms. So let's see how this works in actual operating conditions. This example shows a typical low reflectivity oceanic cell. With manual cal gain selected, only the core of the thunderstorm is visible. In manual max gain, the greater extent of the thunderstorm is visible, and the cores are now red. In auto cal gain, the radar has automatically increased the gain as the outside air temperature decreased, providing a picture that is very similar to manual max gain, and reducing the threat of inadvertent thunderstorm top penetration. Note that at cruise altitudes, manual max gain and auto cal gain are essentially equivalent. In auto, further increasing the gain above the cal position may result in overwarning and unnecessary deviations. In summary, remember that full above and below gain is available during both manual and auto operation. Also, there are three major differences between operating the radar in manual mode and in auto mode. First, when operating in auto mode, the tilt control is inactive. Second, in auto mode, Multiscan utilizes the quiet, dark cockpit philosophy, and weather that is below the aircraft flight path is not displayed. Third, automatic temperature-based gain increases the gain as the aircraft climbs into colder regions, resulting in a picture that is very similar to manual max gain at cruise altitude. Operation in cal gain while in auto is recommended.